I was laughing, the original research we used toothpicks. Until Jane's class had a one-to-one correspondence problem. Bill, Brooks, yeah. And so we went to blunt objects like these. So, and I do have other blunt objects that I like. Matchsticks are actually cheaper and easier. And they fit on an overhead easier. They fit overhead, how funny, that's my world, sorry. They fit on a dot camera easier. I miss the overhead days of the crank. Anyway, no, it doesn't work. All right. I want to show you equations. I have enough time to show you one equation with it. But give me two or three, because when I jump to equations, you're going to say, that's not easy. No, it's not. It shows the concept, and it shows every procedural approach to it. If a concrete object you're using skips a procedure, you got a bad set of concrete objects. Also, one thing we did not get to that actually we put in time for it for when we get back together next month. We're going to use base 10 blocks with the exact same approach. When you use base 10 blocks, is your language here matching the abstract base 10 approach you're using? This is when we went to the Japanese curriculum to do that negative number. I'm not kidding you, that's how we walked into it. Because we kept saying, we're regrouping and borrowing. Why am I moving? This feels weird. And a Japanese mathematician was right there with us saying, why are you doing that? We said, because that's what we do. And they said, no, it's not. Why is this not a negative? That's when we went down that research line. All right. So one equation, you ready? Finish it up with it. Now, this is not going to give the answer, but when we get through this, our initial test pilots, oh my gosh, they were, let's just say they were happy. I'm going to make it an easy equation. I'm going to make it really simple for you because I'm not that bright. So I'm going to go to 2x plus 3 equals 7. So I make a nice, easy number to work this out.
Slow down just a little bit.
Oh, sorry.
Thank you.
It's a new dot camera. We're trying to get to learn to know each other. Epson and I divorced Epson this week. All right. So I've got two groups of x. And then I'm going to add 3. I'm going to try to squish it. I was a bad professor. Hold on. This is not for this grade. I have to separate it. I'm then going to make it equal 7. The first thing you should notice is, this is a lot of stuff. Oh, thank you. I didn't find out those. I hope you notice that this is a lot of stuff. You know why? Because there's a lot of stuff up here too. Each one of the atoms of that long equation, or the products of that long equation, do not make this easy. This is why algebra is really considered an extension of arithmetic. The arithmetic to algebra gap. If you yourself made it to algebra and algebra 2 and you went, oh my gosh, I hated algebra, but I was great in elementary school. That means you really weren't great in elementary school. That means the teachers didn't teach you well enough in elementary school. There should not be a jump. If you find a jump from arithmetic to algebra, that means we have a curriculum issue. I hope that makes sense. So everything we're going to do here, you have seen. All right, I want to solve for x. But I've got all this here. Oh wait, I see a 7. I'm going to make it a positive 7. Because before this, we put a sign for every number. If I get really excited, I just can't fit on the board. I'm going to put a positive over here. I just don't think I'm going to fit on the board. Nope, okay, there it is. It's there. Trust me, it's over there. All right, so what's my first step? I'm going to subtract 3 from each side. That's why the equal sign is a line. So 3 minus 3 here. And on the other side, 7 minus 3.
There's no reason that you did for the subtracting the 3 to kids.
Keep going. Well, you tell me. Why do I want to do this?
Well, so I want to isolate that. You need to move those 3 away, and in order to do that, you subtract it because then you're left with 0 on that side of it.
Now, I don't always use, obviously, the word move, but I want to say I need to isolate what's in these cups of x. So if I isolate x, I want to get rid of, and this is where I say move and making numbers, right? This is when you find yourself going through the funny terms. There's got to be a way to get the numbers over there to make this easier. I know the way to do that. I subtract 3 from each side. What's, guys, same or opposite directions? Opposite. 3 minus 3. 0. Okay, how about 7 minus 3? Opposite. So what do I do? You got to do each group. Okay, am I done? That's no. Now, by the way, if you had a 1x, please divide each side by 2. Okay? So in this case, And this is to keep them awake. Hold on. I'm just keeping them awake. So I'm going to divide each side by what? 2. So I'm going to divide my coefficient by 2 and my sticks by 2. Yes, I don't like the cups. I got to tell you this. But right now, this beach, you know what most programs do? They have, I don't know if I can slide that over. Instead of an X, right, they'll do like 2 in is 2 in. Can't do that. There we go. That is 2X or 2 in for most products. The problem is they're cheating. That's not 2 in. What is that? It's n squared. So you can't do that. So you must have coefficients represented. I'm going to tell you, this is my sticky widget in my research. All right, here we go. What's 2 divided by 2? 1. I don't love it, so I just stack them up. I know that's not clear, but 2 divided by 2 is 1. So I make sure it's 1x. What's positive 4 divided by 2? 2 in each cup. So what's my answer? What is in 1 cup of x? 2. So in my t-chart, I've got x and the function of x. What's in 1 cup? Right? X would be 2 when I have 1 cup of x. When I have 2 cups of x, how many will there be? 2 sets of 2. I get 4 total. Oops. Now that's not how it is. And so then I can keep working. What if I wanted to find out what would be in 3 cups of x? Well, then I'd need another cup with 2. So x would end up being 6 there. It's a function table. The only reason why you go back and start this way is so that they see, okay, for 1x, I have 2. Okay, before we go, because we're at the end, and it's right, we're well past, you know, that time. Margarita's, I know we're going somewhere. Yeah. So answer this one. Pros and cons. Let's go pros first and cons second. What's a pro of any of this cups and sticks method?
Visual.
And it's
Tactile. It's modeling. And I'm modeling using the concrete. How well will students do remembering the procedure? Fantastic. We're actually finding that students have better verbiage during it. When students did just abstractly, we ask them to solve a problem, they silently go through a problem set with you. Well, we're finding that in this one, when you ask them to solve a problem, they start talking through the problem as they move things. So we're getting kids to verbalize mathematics for the first time. What's a negative? Time. Let's say time first. You've got to prep it, the prep time and the delivery time will take. And this one. Generalization, which means when you're done with cups and sticks, what must you do? Pictures of it. And when you're done with pictures, the abstract. In other words, you can't go CA. And by the way, the research, RA versus CRA, is coming out pretty similar. If you've got a good visual, you can bypass it with the concrete. Bad news, if you need to keep the top more, you've got to go to the concrete. Okay, what's another negative of this?
behaviors.
What?
Behaviors.
Behavior. Tell me what you mean by that.
I mean, you're going to have a lot of kids who are still just going to be playing and doing all the things that they do.
So materials management is a big deal. Now something I cheated today is usually when I have the cups and stick stuff, I have big brown bags. And I hand out the brown bags first and I let them decorate. No gang symbols, I told you my world. But they're allowed to have their initials and something to symbolize them. Gosh, love it. I don't know why I allowed that. Okay. Then we let them have bit by bit, piece by piece in their bags. We had a little bin, like a milk crate in the corner, and if they walked in and on the corner of the wall it said C, that meant grab your bag. And it was their bag, and I got to tell you, when we went to the bag method, nobody ever lost materials. That was the funniest thing because it was an ownership issue. And suddenly it became I lost a cup, where's my cup? Someone stole my cup. And then we have to, okay, I'll get you another cup. No, someone stole my stuff. And we have to describe it, we lost it. But we didn't say that, we'll just find another cup. The janitor likes the stuff too. I mean, so anyway. But make sure material management, you're wise with it, and you model before you open bags. All right. Tell me 3 things we learned. Wait. I'm going to go back to PowerPoint. Because I always have closing stuff. Oh, when you go through the PowerPoint also, because I didn't know, you never know how much you're going to get through. Wait for Bill. All right. I made sure I set this up for base 10 blocks, which we'll use more in the future. I also want to make sure you understand we can use those base 10 blocks for equation solving. Right? It's an array model. But I do want to leave you a couple things. Manipulative objects do not teach children. You teach children. You can't just let materials go and say figure it out. You can't say choose your favorite material. You're going to have to give them a material, model the material, and walk them through what happens and why. That has been so clear in research. That's why the National Math Field brought me in. And when all those mathematicians got together, I was the only pro-concrete person. In fact, the U.S. Department of Ed, the government, which is a congressional committee, was going to say no more concrete until we hadn't found the CRA research. So I'm not anti-concrete, but you better be purposeful and planful, right? All right, other parts here. Most primary teachers use it. High school? No. So that's why I want you to know there are alternatives that are out there we need to explore. So anyway, I give you 4 examples. I even make the concrete stuff move so you can see where it's going pictorially. Again, you never know how much we're going to get through. I even have strategies I go with it. Oh, by the way, this is what not to do. I just want to throw that out there. Don't say, you know, I don't really like Brad's stuff, he's a jerk. You're right, I am a jerk. But don't say you're not going to do it because of that. This is a set of tutors that they walked in on, and look what they did to this poor kid. They obviously have tried this, right? You see some equations written down there, they've got a worksheet over here, and then they started ripping up towels and throwing out popsicle sticks because he couldn't memorize it. But look what they did with it. Thirds and sevenths? Are you joking me? Be planful. If it's a concrete day, you're choosing things that multiply into each other nicely. You're not choosing thirds and sevenths. Remember the old standards in 4th grade? They only let you see certain denominators here in North Carolina. I went everywhere with that and said, please follow North Carolina's rule. And even North Carolina doesn't follow its own rule, but that's okay. But I know you're governor, that's why. But when we go through this, there are lots of other ways that I want you to see. So here's my in for you. Some people work hard so they can make a lot of money. I hope that you work hard so you can make a difference. Because that is why that's why PD is so important. So, in this case, I gave you some new ideas. For you, 3 things you'll learn. Give me 3 things that we learned today. I know.
Teach less more.
Teach less, more. In other words, focus on anchor standards. Standards that build and scaffold into each other. If you don't know where the standard goes, question its longevity, good job, Brad. Longevity in the student's life. Give me another one.
Reduce the number of steps to 3.
Reduce steps to 3, because I don't think you go over 3.
You're not going to remember it.
Anybody have children in school right now? Do you teach almost every night mathematics?
Yes.
Yes, because they're teaching more than 3 at a time, and you become the teacher. Because they walked you with some knowledge, and you have to complete the steps. And if you're not doing it, you better question your kid and go, well, she seems to understand it. Question her if she really does, or if she's got a good memory. Why are you doing this? I don't know, the teacher told me to. Now we've got another problem.
Yeah, how do you teach the
Give
parents?
another thing.
How do you teach the parents to do these procedures so that they can explain to the kids?
Next time around, we're going to start talking about, this is my problem, video, your concrete. I love doc cameras, and I always have to get them with because it's the software. Recording functions on your software of what to do, pop it up online. I'm working in Memphis, Shelby County in Memphis. The parents are clamoring for this one middle school teacher. And he's a good guy, but he'll tell you, I am definitely not the best teacher. Well, why do they want him? Every lesson is done on a doc camera with recordings. So when you access his website at night, you see exactly what he did and how he did it, with his language. Which means no matter what you do, you have a full model. So why does every parent want him? Because parents, if we're honest with each other, we know we have gaps in all of our knowledge. Mine was matrices. Steve Duchess used to check on my kids' matrices understanding before he taught them. He goes, whose class? Witzel. Okay. He knows that they probably have no clue about matrices. Because I was like, I kind of skirt around that issue. And so anyway, we all know our weaknesses. All right, one more thing we learned. We're negative 2 minutes, come on. One more thing we learned. Negatives. All right, 2 things you can implement with ease. What can you try next week? The modeling, the different types of modeling. Give me one more. And the chunking. Okay, and the last part. Anybody else want questions? All right, I know you do. Send for some of those questions for me. Thank you for you. Before we go,
Folks, please remember to take your tags and hand them to Jennifer or whoever's at the front desk when you check out. And we'll see you October 27th here.
thank you for you.
Thank you for participating.
awesome.